So last week, we gave you a crash course in web development and web servers and programming languages and the protocol. That is basically, hopefully that's going to be enough to allow you to now go and look at vulnerabilities and to exploit them. So we're going to start with broken access control. And you see that it's labeled with A5. How did it get that label? As it turns out, there's this organization, OWASP, which Allison over there is a member of the local chapter. What is your title there?
Chairperson of the Finance Committee on the leadership team.
Yes, so we are well represented. This is a great organization. I've learned a lot of stuff from OWASP. So we're going to start with their list because their list is more or less a definitive list of the most pressing issues when it comes to web application security. So it's like Open Web Application Security. What's the P stand for?
Open Web Application Security Project.
Okay, so they have a top 10. The last time it was released was in 2017. I think they're now iterating on a new version of this, which means that this class will have to be changed again. So the last time I offered this class, this was before this list got released. So now it's going to have to do another iteration. So the ranking is based on the likelihood of you seeing the vulnerability and the significance of its impact. So if you have one of these things, what kind of impact does it have on your users? And so the top 10 of those, there's way more than just 10 vulnerabilities in web apps, but these are the most severe ones. I'm actually going to cover a whole bunch of the other ones as well, just to give you a little bit more breadth in terms of what is out there. There is a similar list related to cloud security issues. We'll touch briefly upon that list. It's got very similar categories. It's similar exploits, or similar vulnerability categories. Okay, so this is the current version. You see it on the right. The last time I offered the course, it was the stuff on the left. So some of this stuff fell out and some more stuff got added. And so you see right here, A5 is broken access control. So that's what we're going to do today. Talk about broken access control. This one is relatively easy. So I wanted to cover the easier ones first, just to get you going. And then we'll go towards the more complex vulnerabilities later on in the course. And this one's basically and the other thing I should say is that the way I'm going to cover them, the order that I'm going to cover them, is I'm going to start on the server end a little bit more towards server vulnerabilities, where you're developing the app or you're configuring the server. And then I'm going to talk about more client-side vulnerabilities, stuff that runs on the browser. So that's also sort of the organization of the course. So the first part is that you're not protecting either the data on your website or the functionality of your website properly, and especially against adversarial access. So there are many different examples of broken access control. The first one, which we call presentation layer access control, I like to call this security by obscurity. You have some kind of important function, and you give it a URI, and by not disclosing that URI, you're assuming that no one's ever going to access it. As it turns out, this is very poor security. So some examples, you have a special object. Maybe it's a secrets.txt file, and you put it in a place in your website directory structure, and you don't put a link to it, so you think that nobody's going to access it. But then someone will brute force the names and then be able to access that file. Assuming so this is an interesting one. You put the object reference in a hidden field on the web page, and you assume no one's going to do a view source on it. Or perhaps you put an API key in the comments of an HTML file, and you assume that no one's going to do a view source to get your API key. And this actually has happened, where password reset information is left in the comments, and then it gets revealed. Hiding protected functions by omitting them from web pages, assuming people won't access them. So if you have an admin path in your web app, and you were like, oh, that special admin URL that no one else is going to be able to know about, I'm just going to leave it in there, and I'll know about it, but no one else will be able to access it. Turns out people will brute force to find these paths and then find the hidden link. Okay, so the idea with this one, you can just directly forge direct access to these unauthorized functions and objects. And so really, if you're going to do this kind of thing, you have to enforce the authorization on the server. Okay. Another thing is, say you have done some enforcement on the server. Whoops, there's a typo. All right, I'm going to fix that because, whoops. Sorry. Just a little bit anal about typos on my slides. Access controls are not enforced over all URLs to deny unauthorized file access. So one of the examples is protecting only the initial login landing page. So ensuring that people are authenticated or authenticate themselves on that landing page, but then within the subpaths of your web application, you're not checking for valid credentials along the way. So one of the things that if you take the cloud class, Python has this decorator function where you decorate all of the accesses with a login required decorator to ensure that every time you go through that path, the decorator is enforcing that that person has a valid session. You have to make sure that decorator is on all of your paths and that there is no way to access a subpath without being authenticated. And that's this particular one. Another one is not protecting access between functions. So, for example, if you have access to a user's profile, so you're allowed to view this profile, the application must make sure that that doesn't result in you being allowed to access something that looks like this, very similar, but it's to delete the profile, right? So when you are doing the access control, you have to make sure individual paths are authorized uniquely based on what your application needs. Okay, not protecting access between users. So here's an example where an attacker will visit your site and looks at the URL, and if you see this URL, it's some online bank, and it's got some username / get accounts as your path. You have to make sure that somebody can't go in there and change the name of the account and get access to someone else's stuff. So just between these users, you can't have your path be exposed or accessed like that. Okay, another issue is direct object access. So if the attacker notices an account parameter is 6065, they can then try 6066 to see if maybe he or she can get access to another account that's adjacent to 6065. So here's an example, and it's funny, this was blanked out in the thing that I saw, but this is an example of Bank of America giving you an ID number, and then if you increment 6065 to 6066, you were able to get the next account. So this is an old style vulnerability, but hopefully if you're writing a new app, you're not doing this either. Okay, so you would think that this is not a very common thing, but as it turns out, this happens in a lot of places. So last year, the Panera Bread breach leaks millions of customer records, and if you go in and go through the sort of the post-mortem of this exploit, you'll see that, yeah, they were using sequential integers for their account IDs, and then as soon as you could enumerate those account IDs, you log in as one account, and you just go rifle all the way up through the integer space, and then you have access to the entire back-end database of all their customers. So that was last year's Panera Bread breach. This happened more recently over the summer, and this is more substantial. This is First American Financial Corp. 800, almost 1 billion files, and if you look at the kinds of files they were storing, I mean, bank account information, social security numbers, all of this stuff. So if you have any of this stuff, that's too bad because you probably have been leaked. And as it turns out, if you dig down to see what actually was happening, they had these document numbers, And if you incremented this document number in either direction, you got other people's records. So by just enumerating all the different documents, you go from 0 to 885 million. On the document IDs, you can get every single one of those records, unfortunately. And that's why this is in the top 10 still. Another issue is directory traversal. So inferring paths of critical files and then accessing them using directory commands. So here's an example. If you have, this is the way you would go and test to see if a backend server has the directory traversal bug. If you go to a site and it's got a path to a file embedded in the site, say /images/photo.jpg, if you, using Unix style directory traversal, if you would give it this URL where images/dot/photo.jpg is given, if that parameter or that URI is just given into Unix, Unix will traverse that thing and then give you back that file because the // means, oh, just the current directory. So that will actually, if the server is actually just passing that directly to the Unix lookup, that thing will work. You'll get that photo. Moreover, if you do images/dot/photo.jpg, that should result in an error. The first one, unless of course photo.jpg actually exists in the directory above it. And then if you do images/dot/images/photo.jpg, if that gets you the exact same file again, that means this directory traversal has been allowed on the web server. And that should be, I mean, unless you really intended this to happen, that should be a no-no. You don't want people to be you don't want people to be traversing directories on your back-end web server is the idea. Okay, so then you could do something like this. Retrieve some sensitive files by just going all the way to Etsy and then back to Etsy password, assuming that you're this level of embedding down in the directory tree. Yes? So the other thing if you could do this directly, you shouldn't actually do this directly if we are making sure that only images are served from this website. Is that what you're asking? No? We'll talk about input validation on the path name. And whether or not, I mean, because if you're serving static content and you enforce a directory route that's within publicly accessible, if you know that everything in that subdirectory tree is publicly accessible, then you might allow directory traversal, is the idea. But it does depend on your web server configuration. Well, you could filter out the dot. We'll get to this. Actually, I think some of your labs are about filtering out the dots and the dots. Yes. So here's the thing with the dot. If you are in slash and you say // you just remain in slash. So your strategy would put 1,000 of these and then get Etsy password, and this should be fine. Like this should always work unless you're more than unless you're more than 12 deep in the file directory hierarchy. This should get you Etsy password because yeah, // when you're in the slash of Unix will just put you back into slash. Unix does have some limitations, but you're not gonna hit that with this. Yeah, yeah.
Just make sure with however many dots you put in there that you're not going to go over that with how many.
So one of the things that I showed you is document root. You have to make sure document root, everything under that root is accessible because .. will not break out of the document root. So that's another thing. So you'll see in the poorly configured web servers that, yeah, the document root hasn't been set appropriately. Well, your modern web server software should put a jail around your document root and make sure nothing can traverse outside of it. So most web servers do this. But if you're rolling your own, then you might run into this traversal directory issue. Yeah. Any other questions? Okay. So here's an example of some PHP code that that is basically vulnerable to directory traversal. So it defines a file name, and as part of this file name, you say, you know what, I only want this user to have access to files that have this prefix, var files examples. And then what I'm going to do is I'm going to get from the HTTP parameters, I'm going to get some ID. Say it's going to access some file, and I'm confident because I put this thing at the beginning that it's only going to be able, this request is only going to be able to access the files in that directory. But as part of the ID, you could then do the .. /.. to get out of there, to get out of that directory path. And so this vulnerability, it should be extremely rare. But as it turns out, it still happens. So this is Ruby on Rails from April of this year, where the accept header, this is the accept HTTP request header, was vulnerable to a directory traversal. So this is the exploit, the CVE exploit, where you're doing a directory traversal of .. / in order to get access to that backend. I think this one generates an error that emits. In fact, I think I have a screenshot of that. So this is in burp, where they throw that into the accept field, and then it emits the contents of Etsy password back to you. Okay. So really, all of the good scanning tools will catch this. They are programmed to brute force directory traversal across all of the paths that it can find in order to discover this. And apparently for this particular Ruby on Rails distribution, they weren't running that scanning. So this should be part of if you're doing CI/CD kinds of things, this kind of scanning should be done nightly. Anytime someone is changing your website, you should be doing this kind of scanning. And this is what these automated tools do for you. It's more of a software assurance tool. And we'll get to, at the very end of this course, I'll give you some labs that will have you run some of these automated scanning tools at the end. But before just sending you out on the tools, I want you to understand the underlying thing that the tool is checking before you go ahead and automate all of this stuff. Okay, so how do you prevent this? One of the things you could do is eliminate all direct references. So OWASP has a lot of different open libraries that they produce to help you address each of these vulnerabilities. One of them is this ESAPI package, which allows you it supplies this access reference map. And so rather than having a URI that includes a file name like report123.xls, what it does is it takes that file name and it maps it to a random integer. Well, in this case, it's a not so random integer, but it basically takes the name, maps it to an integer so that you aren't able to directly do the access as you would before, if you could predict the file name. So that's what this one is, and so rather than doing this, you would say app file equal 1, and then this map will point you to .xls. The other one is if you have an account ID, rather than having it go directly, rather than directly map this and knowing the semantic of the parameter is the account, you would then instead map it to some random string that doesn't have semantic information in it. And so this is the same thing that we're going to talk about when we talk about cookie design. We don't want any semantic information in anything that the client sees, because then the client's going to modify it in order to get something that they shouldn't be getting. Okay. Validating all references. So when you're trying to validate access between users, you have to make sure every single access a particular user makes is authorized by that user. Enforce any of the role-based permissions that are for authenticated users. So basically making sure you're checking the user and checking the access that that user has on every single access. The other thing you can do is validate the object reference itself. So for example, you can strip out all the directory traversal attempts. Any ... slashes you can get rid of, but this is perilous. Just saying, I'm just going to string substitute ... slash with something else. This is actually really difficult because then you need to make your thing recursive, because there's ways of embedding ... slashes into ... slashes into ... slashes, so that if you strip one pass of ... slashes, you'll still get ... slashes in the result. That's one of your lab exercises, I believe, as part of your Web for Pen Tester stuff. You can blacklist access to all unauthorized page types. So sensitive config files, sensitive log files, sensitive source files. But one of the problems with just blacklisting types is that there are ways to bypass blacklist filters. And we talked about how you could just URL encode special characters to get, so URL encoding is one alternate way of encoding characters in HTTP. You could actually URL encode legitimate characters that on the back end would get translated into the regular ASCII. And then if you're writing a filter, you have to make sure you filter both versions of the character A. So the character A could be %61, %41, or it could be the character A. Now you have to like filter both of those, just in case you see both of those in the encoding. So just doing a string substitution on this stuff, it might seem really easy, but it's not. It's perilous. Okay, the next class of vulnerabilities is the improper validation of input. You'll see that this comes across in other vulnerabilities that we'll talk about. This is sort of the generic class, but you'll see in Thursday's lecture, XXE, and SSRF, this is also an improper validation of input problem, and then cross-site scripting is, again, improper validation of input as well. But we're going to talk about the generic class. So one of the issues is if you have a site that allows file uploads, you have to be very careful that someone's not going to upload something malicious onto your site. So like file sharing applications, for example. And so if you allow the adversary to upload either code or binaries that are subsequently accessed by other users from your site, then they can do something like this, upload a malicious executable that gets downloaded by users, upload a malicious HTML file that gets accessed by users subsequently. If you allow uploads, the malicious actor can upload a size with that's a file that's enormous and cause a denial of service attack on your web site because you don't have enough storage on your back end to serve the file. Here's an example of uploading malicious content, and I think this will show up in one of your labs. You have a PHP site that doesn't prevent the upload of files containing a .php suffix. And so if you are running the PHP interpreter on your server and you allow someone to upload a PHP file that is then accessible subsequently, then that adversary has access to your PHP interpreter running on your web server. So here's something that you could upload. So if you allow PHP uploads, then someone could take a file, and this very simple PHP file could basically upload this into some index.php, subsequently access the PHP file to get the contents of Etsy password. And so that's what this, so the system call within PHP allows you to get an operating system call executed, or operating system command executed. So this is basically a command injection that you're doing by inserting a rogue PHP script. Okay. Typically, if you have this vulnerability, you would want to upload a web shell. So PHP web shells are a thing. Here's a very primitive PHP web shell. So you would upload here, and this is assuming that the victim PHP site has Netcat installed, which, you know, maybe it doesn't get installed, but there's other ways around it if it doesn't have netcat installed. But here's a really simple PHP script that implements a web shell. So netcat is basically allowing you to make a arbitrary connection, network connection to any other destination. So in this case, it says netcat, I want you to execute on the local system a shell, and I want you to send the input and connect up the input and the output of the shell to this IP address using this port number. So it sends an outgoing connection to this IP address on that port. And then what the adversary who has uploaded this PHP shell onto the site does, the adversary will simply on the site that the adversary owns will issue a netcat-L 8001. And then as soon as someone accesses this, the adversary will get a shell on the web server. Okay, so that's the idea. And so there's a library of different PHP web shells here. If you don't have netcat, you can create your own, which is what this stuff is, creating your own. And this, I think this is what, I don't know if they were PHP web shells, but in the Equifax breach, after they breached the Strut server, they had a whole bunch of different web shells throughout the Equifax infrastructure, and they used this network of web shells to exfiltrate all of the data out without being sort of red flagged, because they didn't want to exfiltrate it all out from one machine, because that would look too suspicious. So they ended up running a bunch of these web shells all over, and then trickling out the data, and that's how they ended up getting all of the Equifax stuff. Okay, another issue is the file include vulnerability. So as part of a scripting language, sometimes rather than copying and pasting library code into your file, you'll just say include this file. Include sort of like imports in Python, or in C, the #include for the header files. You just want to include some library code. And so you would do something like this, and if you have an include, and you allow the user, if you take the include from any parameter that the user controls, then you're vulnerable to a file include attack. So the moral of this story is you should never do any file inclusion that takes adversarial input in directly. You would have to validate that input to make sure that that is actually one of the allowed file includes in your application. So this generic set of vulnerabilities would fall under the local file include, where you're trying to obtain a file that's hosted on the web server itself. So in this case, if you had something that looked like this in your PHP code, you could then do something like this, so that this would pull out etc password in this include file, and then you would see it in the results of the execution of this PHP script. Another issue is improper validation of parameters. So you're taking input from the adversary, and then you're using it as part of the logic of your web application. And so as a result, you have to make sure that the input you're getting isn't malicious, or isn't going to cause any issues on your back end. So things like integer overflow and underflow, you would want to make sure before you do any math that you're not going to cause an overflow or an underflow sort of vulnerability. So another one is if you have input that triggers an error condition deterministically and causes the application to crash, you would have to make sure that you filter the input so that that never gets triggered. Otherwise, it's a denial of service vulnerability that gets you to. So an example of this is from last year, BitGrail, where they failed to validate the account balances in their app before allowing a withdrawal from a user. So this probably belonged in the blockchain class, but it didn't get there. It didn't get there because this is actually a JavaScript thing where they did some client-side validation, and then somebody looked at the JavaScript client and was like, oh, I can just directly tamper with all of this stuff. And then they were able to, with JavaScript, to manually withdraw more than what they had in their account balance. Okay? Okay, so some prevention. Verifying all the file uploads. So you have to perform all of these checks on the server. One of the things that people make a mistake on is putting the check in JavaScript on the client and assuming that that's the only way people are going to access your backend web application. Every single check, you could check it on the client to get rid of the crazy stuff at the beginning, but you must always replicate that check on the server backend. Okay? Because people will bypass, in fact, you'll be spending all quarter bypassing the front end and going straight to the back end. Well, the first half at least, you'll be doing that. Do file name verification. So you can create whitelists and blacklists for certain extensions. You can create blacklists of sensitive names. So this crossdomain.xml, this is a configuration file that we'll cover cross-domain sharing later. It's a configuration file that determines whether or not the site is allowing access from random other sites to its content. You can whitelist file upload locations to make sure that all uploaded content goes to a particular location. And you can also use these file rewriting libraries. And what these things will do, and most frameworks have this, if you're taking adversarial input, you will call an API to generate a file name for that input, and a random file name, a random unique file name that doesn't conflict with anything else in the file system. And this way, it provides that mapping automatically, provides that level of indirection automatically, so you're not allowing someone to directly access the file system via a name. Okay, and then you can do some content checking, but it's important that, so this is a double-edged sword. Yes, you want to make sure things like executables aren't uploaded and malicious files aren't uploaded, but like as part of the check, you can't make yourself vulnerable to attack yourself. So sometimes the checking is actually worse than the lack of checks. But if you have gotten the content checking down, then you can filter, you can disallow all binaries in uploads. You can disallow those PHP scripts. You can disallow known vulnerable sort of file extensions. But the problem is that executable malicious code can hide everywhere. And in fact, in the, I think in the optional slide here, I can point you to one of the favorite ways of hiding vulnerable code is in PDFs. So PDF, if you have time to watch this YouTube, PDFs can host all sorts of, and this is not something that the file format can fix. PDF can actually host all sorts of malicious content, executable content within it. This is why for quite a long time, PDFs were the main target for delivery of malicious code on user systems. But I used to play that, but now I think I'll just point that to you. Okay, so this gets me to labs and homework. I do want to give you time in class to work, which is what hopefully you'll have a lot of time, because what I'm going to do is just go through at a high level what I'm expecting in the labs and the homework. I'm going to show you different ways of solving the homework using different tools so that you have options. So if you really hate Postman, which I think some of you by now really do hate Postman. I hate Postman too, but I'm going to show it to you anyway, just in case you like the GUI. I'm going to first talk about the labs. So the labs, when I assign a lab, these things are intended to be completed by the next class. I really want you to, once you get the lecture material, to finish all the labs. And so you'll see that the lab notebook, those things are going to be due soon after they're assigned. So as part of the lab completion, I also want you to include a screenshot with your Odin ID in order for the TA and myself to be able to validate that you, in fact, have done the labs. But you can actually collaborate on the solving of every single lab exercise in this class. Throughout the code labs, you'll see that for specific levels, I'm going to ask you to include additional screenshots, not just the level completion one. As you read through there, just read the instructions carefully, because if I ask you for a screenshot, I'm expecting that screenshot to be in your lab notebook. Let's see. And really, the code lab is meant to make the lab easier. Like the text that I put in there, it's meant to make it more understandable so that you can solve the level faster. So you could be tempted to just skip all the description, but that in fact might make it harder to solve the lab, is the thing. Okay, so for this set of topics, there are 3. So if you look at the code lab, and some of you have already started this, there are some labs associated with the file path traversal. There's some labs with the file upload, and then there are some access control labs in the different virtual machines. So that's what I'm going to have you do before Thursday, hopefully. As you have also seen, there's this homework site. And as part of this homework site, I recommend that you do these homework levels the week that they're assigned. And what I'm going to do is, as I give the lecture material, I'm going to open up the modules that are associated with it. But I'm only going to check for completion the Sunday after finals week. So if you're going to fall behind in this class, fall behind on the homework. So, yeah, because that's the only time I check the homework. And I do not want screenshots of the homework. The homework site is built to automatically give you a result key that's bound to you, so I know that you solved it. There is that. I have also enabled all the cheats on the homework levels. So again, I mentioned this in passing last class. Try and struggle a little bit before you go to the cheat. In the code lab, when I talk about levels that I ask you to go straight to the cheat, go straight to the cheat, because you'll never be able to solve it otherwise. Or it'll be way too difficult to solve otherwise. The idea is not to get you stuck for hours on a level. The idea is to go more for quantity of exercises. And so if you find yourself stuck, I would say more than an hour on a level, you should be slacking me or the TA, and we'll be happy to try and get you unstuck. Okay. Okay, so what I wanted to end with is a walkthrough of a level, insecure direct object level number 1. And I want to show you how to solve this a bunch of different ways. And you can choose the way you want to solve it. In fact, you could choose to do all the different ways just to really get your practice in with the tools. And that's what I would recommend. This is basically getting you making you comfortable with the tools that people are using to attack these web applications. So the first part of this, which I showed you earlier, on each of these levels, typically there is a level that looks like this, and so this is for insecure direct object number 1. You've got this web app that allows you to show the profile of a particular user, and the result key is stored in the private message for a user that's not listed. So what you would do is you would right-click this and inspect it, and you inspect it and you see that this is the HTML that's associated with it. It's got that LE form as the ID that invokes some JavaScript to execute the form submission. And you see here the form submission has values for each one of these users as 1, 3, 5, 7, and 9. So that should clue you in as to, hey, these user IDs are odd numbers starting from 1. And maybe if I send in an ID of 11, I'll get a user that exists but that I shouldn't have access to based on the UI. So this is presentation level access control, where they're not expecting you to hit user ID 11 because it's not part of the UI. But you will go and do it anyway. So that's how you solve this level. What you'll do is you'll find the JavaScript associated with this form submission, and it looks like this. You see this AJAX call, $.ajax. It's got a post, it's got a URL, and you see the actual format of the form submission, so user ID with the option value. So then what you're going to do is you're going to examine the AJAX request when the profile is requested. And so what you can do is, in your browser, you can go to the site, which I have over here somewhere. So I'll log in. I'll get myself a developer console. I'll go to insecure direct object. Go to number 1. I'll look at the network connections, and then I'll click on a couple of these things, and I'll say show this profile. And then you should see over here, you see the response that says that, well, you see the HTML that's there. Let me get this over so where you can see it. This is the form submission. Wow. All right. Guess I need to make this bigger the other way. So if you go into the headers, you'll see down here at the bottom, you'll see the form data. I highlighted the first two, and you see that the form submission has this format in terms of the fields. You can't really see this, but this is user ID bracket bracket :1 and user ID bracket bracket :3. So when I highlighted the first two, it submitted as part of the form submission these two things. And so then the idea is that you want to create another call that has a form submission that has the user ID of 11. Okay, that's the way you solve this thing. Let me go back to the slides because there's some JavaScript I want to show you. So I actually had it as a picture here. I didn't need to do that. This is a picture of just highlighting the first one. And so if you did the first three, you get 1, 3, and 5 on the bottom. And so the first way I'm going to solve this is with JavaScript in the Developer Tools console in the page context. So when I'm clicking around on the response, so I submitted 1 and 3, and then I highlighted that request in the Developer Tools. Now, in the console associated with that request, I have access to the entire page's context of the request. So I have access to the cookies that page has access to and all of the elements. And so what I'm going to do is I want to modify, or I want to create my own AJAX call, and I want to use the JavaScript interpreter running on that page to execute my AJAX call, and I'm going to supply the AJAX call with a user ID of 11. So I went and I looked at I reverse engineered the form submission JavaScript, and I just copied and pasted that call over to this. So that's what I'm going to do here. So here is an AJAX call. I figured out the URL based on inspecting the elements, and I'm just going to copy this. Whoa. If I could get my... Bear with me. Actually, I'm going to instantiate this JavaScript call in the browser. I'll go to the console. And so this will, in the context of this page, create another AJAX call. Not found. What? Hang on. Let me make sure I have the right... Let me make sure I have the right... Oh, man. I hate hacking on this thing. No, that was the right one. All right, hang on. No, I didn't want that. I'm going to try this one more time before... I might not have been on the right context. So then this should show me that I have user ID of 1. I go to the console. Whoops. Oh, I am not in the right context, so hang on a second. I need the challenges. Whoops. I thought it was in the challenges context, but... So that will actually submit that form. So I thought the base, I didn't set the base. I thought the base was set to the challenges path, but it wasn't, so I had to add. The form submission is in the challenges path. And then what you can do is, after you have made this JavaScript request, this AJAX request, you can then get the response text. So AJAX call dot response text. And then you see the result key here. Well, it's dark red, but that's the... If you were to run this on your browser, that's what you would get. Okay? Are there questions about navigating the JavaScript console to solve this level? All right. So that's one way to solve it. Here's another way of solving it that might not work either, based on whether technology likes me today. The next way, I want you to see the solution of is Postman. With Postman, you'll be able to do the form submission, and when you highlight the form submission, it'll give you editable fields. And when you edit these things, you can just resubmit using the edited fields. So let's show this happening. I have my Postman set up. One of the things, let me clear this for clarity. One of the things that you have to do that I failed to mention in the other class, in the previous class, when you set up Postman and you connect it up, you have to turn on cookie collection, because what's happening is the request is going to the website, and in order to authenticate you on that website, it needs a cookie. So you want Postman to capture cookies, and so I have it set up to capture all cookies going to OregonCTF.org. So then what I'm going to do, so the interceptor is on. What I'm going to do is go back to my web browser. The request capture is on for OregonCTF.org. I'm going to go to the website. I'm going to log in. And then on this website, you should hopefully see these requests on the left for OregonCTF go through. On the challenges, I'll go to the challenge level. I'll highlight the first one. It'll give me that message. I'll go back into Postman. You see the post that happens. The post in the body, you can see the user ID of 1. So then I would set that to 11 and then resend it. And then you would see the result key showing up. So ideally, that's the way Postman should work. But people have been wrestling with, I've gotten a number of messages with people really hating on Postman for a good reason. So, but Burp is not any bit like, Burp is hard also to get up and running. My preferred way that gets rid of all of the tooling. So here's the problem with tooling. The cognitive load of figuring out how another person thinks and how they express it in a UI is too much for me sometimes. Python never fails me. So the last way, which is my preferred way, and this is the way if you're having issues with your levels, I'm going to debug it using my Python scripts, not any GUI. Yes.
So is the takeaway that all levels can always be solved with Python?
Pretty much. Yeah, when in doubt, Python, that's my mantra, but like, I'm happy to use tools. If you want to learn them. So there are so many tools out there. Yeah. There are so many tools. I encourage you to explore the tools that work for you. So if you find a tool that you love, and I know some people love Burp, but you see, you need the tool that matches your level of cognitive tolerance, I should say. I don't have a lot of tolerance for too many things to learn. Like you see some of these tools, they have like thousands of features in them. Like for this class, there's like very little that you actually, like, there's a lot of stuff that's being automated, and if you're doing this professionally, you will get there. You will get to a point where you can understand what that tool is doing and what that tool is automating, and out of necessity, learn it. For you as a beginner, I would suggest minimizing your attempts to learn new tools. So learn Python. Python will do you well everywhere. So if you have to solve these levels, if you're running into any issues with these tools, go back to Python. And so the last thing I want to do is show you how to solve this level in Python. And I'm going to show you the script and then walk you through it. So this is how you would do it with Python requests. You create a session because you need to keep the session cookie in order to validate that it's you. This is the login URL to log in. So you can copy and paste the first 4 lines into every script that you're going to use to solve the levels in this homework, because this is all authenticating to the CS495 website. And then you have this session, which has your session cookie for the site. And then what you do is that post endpoint has this URI that you can get from reverse engineering the form field. So that's your URL. And then you do a session.post to that URL. And the data is this user ID 11. And it's done as a dictionary. And this will get URL encoded. This is the format is www.url encoded is the format that this will get posted into. And then you just print the response.txt. So this is what I prefer. And so what I'll do is I'll copy and paste this. Because this is a CS program in particular, I can just assume that you'll either know Python or will learn it. And actually, I think I copy and pasted it here. So this is the exact same script. And then you would just run the script and get the result key. Okay, so that's the Python way of doing that. So all that code is in the slides, and the PDF should be in there. So that's all I have for today. I will just let you have at it and solve all those levels in the code lab. Are there any questions before I think that's it, before I let you go? Okay.